the hydrostatic force of a circle?
Yeah.
Yeah. Okay. That's a good one. It's a hard one, but it's a good one. Right. Let's do the white screen. So here's the top of the water. We're going to do it in feet and pounds. So the magic number for feet and pounds, 62.5. All that number is therefore is whatever my answer would be, I'd have a 62.5. It's the weight in pounds of a cubic foot of water. So we have a circle here. Okay. And I don't know what I'll make the circle. Let's make the circle a radius of 6 feet. Okay. Actually, just to make my life a little bit, I guess it doesn't matter. Yeah, we'll do that. We'll have this distance here, 2 feet. And I need to add some more lines. Let's put a little invisible dotted line going that way. And we're going to have a distance from here to here, which is going to be called the depth. And that's going to go to this fella here. So what I'm doing is I'm looking at a typical strip on this shape at some depth, which I'm going to call, well, we'll figure out what the depth is in a minute. In this particular question, we know what the formula for the hydrostatic force is. It's going to be 62.5 because of that guy. The integral from some number A to B, which is to do with the depth, right? And what else? Can you remember what goes in here? Doesn't need to be specific, but just general.
The width and
Correct.
The depth.
And the depth. Now, everything has to be converted into x's. So when I talk about the depth, it's the distance from here to the strip. And when I talk about the width, it's going to be from here to here, right? And we have to figure out what this distance from here to here is called the width in terms of x's. And that's pretty much going to be the hardest part, I think, of the whole thing. So I'm going to call, well, I guess I'll put it here. I'm going to call this guy here a half W and this guy here a half W. Because isn't that vertical dotted line breaking into two equal pieces? And I am going to call X the distance from the bottom of the circle to there. And I'm going to join that guy to there. And I think I should be good. Let's just check. No, I'm not. That's not a good triangle. I mean, it's a triangle, but not a good one. I want one that uses a radius. So let me change my orientation and use that triangle here. Okay. So we have a little right angle triangle, and this distance is a half W, and this distance here is a radius, so that's 6. And unfortunately, I need to know this distance. I think the one I did was a half circle, which is much nicer, but too late now, doing a whole circle. So the distance from here to here, well, that whole thing is 6. So this is 6 take away X. Are we good with that? Are you happy about this triangle here? Being this triangle here. This distance is a radius 6. This is half the width, so I'm calling it half W. And this distance from here to here is 6, take away x. Right, from this relationship, can't we use Pythagoras? So 6 squared is 6 take away x squared plus 1/2 W squared. So if I solve for W, I've got my width. That's going to be 36. That's going to be 36 take away 12x plus x squared. And that's going to be 1/4 W squared. So what do I get? If I subtract this and this and this, I get 12x take away x squared, which is 1/4 W squared. And I get 48x take away 4x squared is W squared. And so W is the square root of that guy. So I know the width. It's a square root of 48x take away 4x squared. Right, now the depth. The distance from here to the bottom of the circle is 2 feet plus a 6 plus a 6. So that's 14. The distance from here to here is x. So using the fact that the total distance is 14 and this little bit at the bottom is x, what is the depth in terms of x? This is 14. This piece is x. What is the depth?
14 minus x.
Okay, there we go. Okay. What will the depth be at the top of this circle?
Two.
Okay. And what will the depth be when you hit the bottom of that circle?
14.
And that ugly guy is the hydrostatic force. This equation is not, it's not possible to do this integral algebraically. So all you would do is plug into your calculator and get, 15.1234 and call it good. I think the one that we did the first time was actually much easier, which is only half a circle. If you do half a circle, the math comes out a lot cleaner. But if the integral is not a valid integral, by that I mean one that you can actually solve exactly, then the question would just be, give the answer to 3 decimal places. In a funny sort of a way, it makes the question easier because isn't that just TI-84 stuff? So you plug it in. That was a totally a question. Right, what's the
I
next
have
one?
a question for that one.
Go for
Why 6 minus x there?
Why 6 minus x here? Okay. So
Yeah.
I've got my big circle. Right. I've got my guy going this way. I've got my guy going this way. Now, that's 1 to here is 6. And the reason 6 isn't it is a radius.
Yeah.
Right. And this distance here is x. And this total distance is 6. So the distance from here to here is 6 take away x. And that distance was the other one. So it's 6 minus x.
Oh, okay.
Because it's 6 to there, take away the x to there.
Okay. That makes sense. Thank you.
You're welcome. Okay, give me something else to go over.
An area, the surface area of a conic.
Oh, God, they're hard to make up. So let me go find one. That way I could use, if I just made one up, I'd end up with an integral that's got a good chance of not coming out pretty. And one of the things you want to get out of a surface area question is that the bit that goes inside the square root, you want it to be, if at all possible, a perfect square, right? Otherwise, the algebras are horrendous. So, okay, so let me find one where that hopefully should happen. I'll try this one. Well, let me check with the answers, because that way it'll tell me. Excuse me. That'll tell me whether I'm going to get one of those perfect square guys that I want. That's not a perfect square, so forget that one. Yeah, okay. So it's this curve, and we're being asked to rotate it from 0 to 9, and it's going to be about the x-axis. So if I did the square root of this guy, it would start about here, and then it would curve like that. And we want to rotate it from 0 to, let's say that's 9. So that's the thing that's going to be rotated. It's going to be rotated about the x-axis. You could stick that in Desmos if you wanted to be sure about it. Okay, so surface area has a very distinct formula. It's an integral from A to B. Anybody want to fill in the rest? Because you got to know it if it happens in the final.
Is this the 2 pi times the square root of 1 plus the derivative squared?
Almost.
Oh, y?
2 pi, yeah, why, sorry.
Y or f of x. I'd call it f of x because in this format, don't you want everything to be x's? But 2 pi y works in a different context. Now, in this case, the integral is going to be from 0 to 9. The f of x is this guy. And then we have to do 1 plus the derivative squared. So I'm going to do that at the side. And we are going to find out what the derivative squared looks like. I'm going to write the square root as a half power. So to differentiate it, it's going to be 1/2, 1 plus x to take away 1, technically times 1, but I won't bother writing that. So the derivative, if you make it look pretty, looks like that. If you take the derivative and square it and also add 1, you get 1 plus this guy squared. What does that get me? 1 plus 1/4, 1 plus x. So it's not a perfect square. What am I going to do next algebraic? Because it's the algebra is the killer in these questions. Do you think I'm going to leave it this way, or am I going to do something?
Add them together by multiplying both sides of the 1 by 4, 1 plus x.
Okay, so you got this guy. What's that guy? And so what do I get? I get 4 plus 4x plus 1 over 4 lots of 1 plus x. Not very interesting. I was hoping for a perfect square, but too late now. What the heck have I got under here? Get a bump. Still got a bump. Still got a bump. There we go. Well, you know, don't always get perfect squares. It would be nice if you did. Of course, if you were doing arc length, you better get a perfect square because you're probably not going to get out of it if you can't. So I have got 5 plus 4x. Oh, well, we've actually done all of that, haven't we? So we should rewrite that as 0 to 9, 2 pi the square root of 1 plus x, followed by essentially the square root of what we've got here, because that's what 1 plus the derivative squared looks like. And again, it's going to be a problem with algebra. That is definitely not an integral you'd like to do. So what are you going to do to make it look pretty?
We're gonna separate the denominator and numerator into square roots and cancel out the 1 plus x.
Sounds like a plan. Square root, that gets you 2. And then you kind of go, that's kind of clever. Because that cancels and that 2 cancels and I got a pi. So I probably bring the pi outside. And we're left with a much simpler integral than we started. Sometimes people don't, oh, you know, what's that phrase? You can't see the wood from the trees. They don't see that this is a relatively straightforward integral. But they have to think of a better way to write it. Would you agree that the square root of 5 plus 4x doesn't really help you integrate it? Right. So what would be a better way to write that square root?
Did you do a U sub for this one?
You could, but I think that's thinking like another step ahead. Let's just figure out how to rewrite this. You won't be
For
able
the
to do a
1/2
use.
power?
Yeah. Now you could do a U sub at this point. And if you did, the U sub would be 5 plus 4x, and it would work totally fine. Or you could use a shortcut. Can't you just add 1 to the power? Divide by the new power. What have I missed? And it's because of this 4x. What else do I put here and we're finished? If you did a U sub, you'd end up doing it, you know, anyway. But what would we do if we do this shortcut? It's called the linear shortcut method.
The 4,
Is it times 4 or times a quarter?
a quarter.
All right. So all I'm doing in the next few lines is trying to make this pretty. That partially cancels and I get a 6. That guy is the square root of 5 plus 4x cubed, evaluated at x equals 0 to x equals 9. I would probably pull out that 1/6 as well while we're at it. Let's see what we get. If you plug in 9, you get 36, and 36 add 5 is 41. Square root. And if you put in 0, you get that. I don't think you can make that look pretty, so you're finished. You okay with that one? Actually, now that I've seen it, I'm kind of happy it wasn't a perfect square because, you know, the algebra that you needed to do here was a little bit different. Perfect squares are really nice because then they cancel out with the square root, and that happens. That's good as well, but not this one.
For the test, we're gonna assume that the thing will be able to simplify.
Yes, you're going to have to assume that you can integrate, right?
Okay.
Because if it's not, I will tell you by saying, give the answer to 4 decimal places or something. So if you ever see that, You know,
That means the calculator
yeah, it means basically, I guess, get to there and then just stick it in your calculator.
Okay.
Actually, you could probably, you probably get it to here and stick in the calculator, because you don't even need to do the algebra to make it look pretty, because the calculator doesn't care if the thing looks pretty or not. You're still getting the right answer.
Yeah.
I don't think I put any questions where you were being asked to do it to 4 decimal places. So
Okay.
from what my memory serves me, all of them work, or they better work. But if they don't work, I'll find out, and I'll change it. Okay, what, any topic next, or just any question really, anything to do with the test that's coming up? I know some of you are already signed up to get the next class, aren't you? Okay, so that's good.
Yeah, I need to do that.
Oh, don't say it like that, it's depressing.
I get you for 2 classes.
2?
Mm-hmm.
What's the other one? Oh, a stats class probably.
Yep.
God, David, you're crazy. Could you have taken somebody else? That's good. You're going to get the same jokes twice every single day. Well, maybe not every single day. I'll forget which jokes I've told people.
On the last question,
This
what
one?
do you get for A and B? Or no, the question we did before this.
I think I did from the bottom to the top. So what was that number? I said 2 to 14. I think that was the numbers I picked.
Okay.
I'm doing it from the depth. So depth is, guess I could have done it in terms of X. Would it make any difference? At this point, X would be 0, and at the top it would be 12. So I could probably do it from 0 to 12. You might end up with the same answer.
Okay.
0, 14 to 12. Yeah, you could do it using the X's. And if you did it from the X's, X's would be 0 at the bottom of the shape and 12 at the top.
Okay.
Actually, it'd be 12 to 0 because you're going from the bottom up, not the top down. But you'd figure that out anyway, because hydrostatic forces have to be positive. So if you got a negative answer, it just means the 2 integrals should be switched.
Okay.
Any other topic? Anybody came in, just wanted to find out one thing and leave, or whatever? You know, it's totally open-ended. Don't want to have you hanging here if you've got
Do you
things
do
you
it?
want to do.
Oh, sorry.
No, go for it. What?
Could you do an X sub?
An X sub? Yes, I could. I do not want to make one of those up. They take forever and a day, don't they? Let me look at the past section. So the X subs are called trig substitution. I think it's the name in the textbook for them. So that would be 7-3. What I would call X subs anyway. Let's see what we've got here. If you got an X sub question, not saying that you will, but if you got one, you would be told what the X sub is. I wouldn't tell you what the U sub is, but I would tell you what the X sub is. But there are only 3, isn't it? Sine theta, tan theta, or secant theta. Well, 2 sine theta or 5 tan theta, but it wouldn't take you long. But I would just tell you that. Right, I'm trying to find one now. Gotcha, view it. Why don't I do this? That's an idea, I thought. I've got the questions here in front of me. Why don't we do a quick scan through them and you tell me which one you would want to do, because I might pick one that wasn't the one that was causing you so much trouble. Right, so here we go. The first couple of questions just ask that you set it up, so they're not really valid because the answers might not work perfectly. So here, the ones that kind of begin. How about that one? 7 or 8 or 9 or 10, because they take forever in a day. So 6 to 10. Any particular one you want me to do?
Any works.
Anyone works? 8. Don't know why. Just stopped at it. So it's the square root of x squared take away 64. And on the bottom, it's an x to the 4, which is fine. Let's go to the working. See how we would approach this guy. Right, so we'll assume that you've been told what the x sub is. Does anybody know what the x sub's going to be in this question anyway? Any suggestions? Nothing?
Is it tangent 8?
So you're saying 8 tangent?
Yeah.
Not quite, but you hit the crossbar.
I think it's secant, right?
Yes. And an 8. Yeah, that's the one. But you be told it, so it's not that big a deal. So you might say, well, why? What would the difference be? If that had been x squared plus 64, it would be tan. Because the two guys added, you know, a tan squared plus a 1 gets your secant squared, right? But you need a kind of secant squared minus 1 to get you a tan. It's for that reason. But this one's a different test. You got to have your differentiation hat on. And secant, what's the 8 secant theta's derivative?
Secant tangent.
Correct. If you were thinking right now, I don't know, shouldn't you write that down somewhere? You have it in your list of things, I know. Right, now if you do the crossover, you typically only need 3 instead of the standard 4 in these questions. So what do I have? I have the square root of 8 secant theta squared, take away 64. And on the bottom, I have 8 secant theta to the power of 4. And instead of dx, I'm going to have 8 secant theta tan theta, d of theta. Okay, that guy inside the square root gets you 64 secant squared, take away 64. This guy here, I'm just going to call it 8 to the power of 4. If I need to know what the number is, I'll do that later. And I'll have an 8, I'll have a secant, and I'll have a tan, and a d theta. Are we comfortable so far? Right. What on earth does 64 secant squared get you?
Is the dx supposed to be equal to 1 over the 8 secant over tangent?
Here? No, you do the crossover. Dx times 1 just gets you dx, and all of this times it. So it is 8. It's not 1 over 8.
Oh, okay.
That's what you're saying. Right. What's that guy inside the square root eventually going to be? (64 secant squared, take away 64. It's one of those trig identities, isn't it, as well? Can you remember what secant squared take away 1 is? Because this is just 64 of them.
Tan squared?
Yeah. So you get 64 tan squared. And I'll I'll leave it as 8 to the 4. I'm kind of committed. I could actually start tidying up. Just because I want to. I'm just not going to do it quite yet. All right. That guy is 8 tan theta. That guy is 4 secant theta tan theta. And this guy in the bottom, why did that turn into a 4? It's an 8. And this guy is 8 to the 4, that fella. Okay, time for some carnage here. Anything I can cancel, top and bottom. And I keep wanting to turn that into a 4. I have no idea why. Something in the top cancels with something in the bottom. What could that be?
The 8.
Okay, so that 8 and that 8 cancels out 2, then won't that leave you with 8 squared? Is there anything else on the top and bottom that we could cancel right now?
Turn secant to the 4th to secant to the 3rd.
Okay, so cancel a secant. Right. Now, it looks a bit messy, so maybe I should rewrite it with pieces that are left. There's a tan squared left, and there's a secant cubed left. And one of the there's many things in trig that cause problems. One of them is that just because something looks like this doesn't mean it has to stay looking like that. Right now, I can imagine some situations where that would be fine. But if I try to do a U sub right now, the candidates I've got are secant theta, right? U sub equals secant theta or U sub equals tan theta. I don't think I like either of those two because they don't do anything. So is there any other way to write secant cubed theta on the bottom?
It would be just cosine cubed on top.
Okay. It's still not doing me any good, but it's closer. Is there another way of writing a tangent?
Sine divided by cosine, or sine squared divided by cosine squared.
And won't they partially cancel and leave you with cosine? And that means that we now have sine squared theta, cosine theta, d theta. If you ever get an integral that has any of the trig functions in it, right? There's 6 trig ratios, but the way it's written isn't working for you, right? There's no obvious U sub that gets you out of trouble. One of the strategies is turn everybody into sines and cosines. They're much simpler building blocks, aren't they? Would you agree that this question can now be done with a U sub? So what U sub?
Sine.
Correct. Why did you pick the sine?
Because the derivative of sine is cosine, negative cosine, and it cancels out the cosine.
Sounds like a plan to me. So the derivative of a sine is a cosine. It's a derivative. And the crossover. And then divide both sides by cosine to isolate the d theta. So there wasn't a negative involved with that. It's fine. So what do you get? Yeah, u squared cosine theta, 1 over cosine theta du. The cosines cancel. And so we end up with 1/3 u cubed, which becomes 1/3 sine cubed. But that's not us finished. We have to get everything back into x's, and then we're finished. And that involves creating a little funny right angle triangle. And the guy that we're going to use to help me label the sides of that triangle is that. Right, our x sub. Now, if I divide both sides by 8, we get that. I don't like secants, they're hard to figure out what they are. Won't a cosine be 8 over x? Right? Isn't a secant just a reciprocal of a cosine, and a cosine is just a reciprocal of a secant? And we know cosines because that guy is adjacent and that guy's hypotenuse. So I always try and get the original one to be either something with a sine, a cosine, a tangent, right? One of the SOHCAHTOAs. So I can build my right angle triangle. Call this guy theta. And we're going to have an adjacent, an opposite, and a hypotenuse. And according to this, the adjacent is 8 and the hypotenuse is x. And so according to Pythagoras, we should be able to get the opposite. And the opposite is x squared take away 64. Why is that a good sign?
We had that in the beginning.
You see it? It's always a good sign. Now, our answer was 1/3 sine cubed theta. Well, I can use this triangle. Won't the sine be opposite over hypotenuse? So it's going to be 1/3 opposite over hypotenuse cubed. And then we make it pretty. So x squared take away 64 cubed over 3x cubed. And that was a pretty standard x sub type of question.
Where did the 64 go?
Where did the 64? It's still there.
I mean, we took out a 1/64th, like a few pages back.
Okay, let's see where we did it. We had the 64 here, right? We pulled it out. Did I lose a 64 somewhere? I did, didn't I? See, there's a 64. Right, and 1 over 64. So I'm just sticking it here at the end. So we are now going to be 364 is 180, 192. Yeah, that's where the 64 went. I missed it. Luckily enough, that one was an easy repair because it was only a constant that was, you could just put it through the entire question. It wasn't going to change the algebra. Well, unfortunately, we are kind of running short of time. I'll be free in the office, so if you want to come in at 10, because you may have another question that, or a topic or whatever, I will see you then. I don't need attendance because you've all been given attendance for today, even if you're not here. And that report that you've got already included today in it, so it's not anything's going to change.
I
Oh,
have a super quick question.
Go for it.
For those X subs,
Yes.
Just technically, would you be able to say theta is equal to the inverse secant of x?
You would get dinged for doing that. And by that, I mean, this is the style point answer that we're looking for.
Yeah.
If you just called this, well, what would you call it? 1/3 sine cubed of, in brackets, the inverse secant of, oh God, whatever. It would be somehow run. Nah, it wouldn't be pretty, so it wouldn't be considered. So don't do that.
Yeah.
The only
but
time you
just,
should do
just
it,
technically, would that be correct?
it would be correct in the same way that 2/4 is a half,
Okay.
but it's not correct. Now, there is
Yeah.
one special case. Can you imagine that your answer was this guy? Right? Yeah.
Yeah.
That would be okay to call it inverse secant of x over 8. That would be totally acceptable. Because,
Okay.
but if there's any kind of sine, cosine, tangent thing going on, you must build your triangle.
Okay.
Okay. Any other questions? Otherwise, bye-bye, guys.
I have two quick questions.
Yes.
Me too.
One is, are we gonna be able to show up 10 minutes early for the test like the previous one?
Yes.
And also on the practice final, if
Yes.
we get the right answer but go through slightly different on the process than what it says, is it still fine?
Yes. The only caveat to that is it must be mathematically correct. It is possible for you to do it wrong and make 2 mistakes that cancel each other out and still get the right answer. I'm not saying that's what happens, but if it's good math, it doesn't mean there's not a problem with that. You get full points. Right? So some people use UDVs, for instance, when they're doing integration by parts. I have no problems with that. You might have came up with a different approach to some of the other questions. That can happen, and I'm okay with that too. As long as it's good math, we're right. So you should be fine.
Okay.
I keep wanting to get rid of you lot, but that's because I've got another class to get set up.
I have a
Oh, by the way, in Canvas, there's all the information you wanted. I've sent it in there, so if you have a look at it, what's it called? Final exam information. It contains a Zoom link. Most of what's there will stay. The things that will disappear will be the practice final and its solutions for obvious reasons. And yeah, that's probably the only one I need to take out. I think everything else can stay, because you are allowed to use Desmos, for instance, to sketch things. So I'm leaving the Desmos in that module.
My question was just, I'd asked for extensions on a couple of the homework ones that I got like 90s on, just so I could go back and finish the one problem I missed.
They are gone, Stefan. The only thing you can do is send me an email telling me what your answer would be, and if it's correct, I will change your grade. But they're now locked.
Oh, okay.
Yeah.
All good. Not a problem. Sorry. I was going through last night and I was like, oh, I missed some stuff. And then there's one I got a 30 on, but can't be helped. All right.
Yeah, in the big scheme of things, one homework really doesn't do that much damage.
No.
So you find your overall homework grade. You'll be able to actually tell, Stefan, if you look at your final report, what your final homework assignment grade is.
I'll take a check in just a sec. All right. Thank you so much. Bye-bye.
Okay. Bye-bye, guys.
I have a question.
Yes,
Sorry.
Maggie, go for it.
All right, so I actually have a few. So
Oops.
the first question is, do you have office hours tomorrow? Because I won't be able to
No,
make it
I
today.
don't have officers tomorrow. I'll be taking in the final, one of my first finals tomorrow, so I'll be busy doing the final, and then after that I'll be grading. So
Okay.
you won't be able to get me.
Okay.
Your other questions?
Yeah, what's the difference between the two practice finals in Canvas? Is there any major difference?
I can't even remember that I put in two. I probably found an old one and a new one. I think one of them has the differential equation stuff in it and the other doesn't. And I think one of them's bigger, and so it's got more examples.
Okay,
So it's just more resources. There's nothing. Don't read anything else into it, apart from the fact it's stuff that you can use to revise with.
okay. And then on the exam, are we going to be expected to draw a direction field?
Probably not draw it, no. But what you might be asked is, here are 4 pictures, because I've drawn them. Which one's the direction field?
Okay, thank
But
you.
if you got that question, it would be in the multiple choice.
Okay, wonderful. Thank you.
Okay.
We have